Hi, my name is Abamel Hernandez Jimenez,
I'm Yongja Song.
and today we are going to talk about our cross-linguistic study of QD manipulations and how they affect scope ambiguity resolution. Imagine a scenario in which there are two horses and a fence, and one horse jumped over the fence and one didn't. Could you describe the scenario with the sentence, "Every horse didn't jump over the fence"? Previous studies found that children don't endorse this sentence to describe the scenario, but adults think the sentence is a good description of the scene. This sentence is interesting because it's an instance of quantifier scope ambiguity. There are two possible sentence interpretations. Under the surface scope interpretation, where every takes scope over the negation, the sentence means that none of the horses jumped. Under the inverse scope interpretation, where negation takes scope over every, the sentence means that not all of the horses jumped. Importantly, in this scenario, only the inverse is true. We might conclude then that children can easily access the surface interpretation, but they can't access the inverse, so they don't endorse the every not utterance when only inverse is true. Adults can easily access both interpretations, which would explain why adults do endorse the utterance. However, if we manipulate the contextual information children receive, we can change their behavior to be more adult-like. That is, we can lead them to endorse the utterance more. One aspect hypothesized to affect endorsement behavior is the question under discussion, or QUD, the topic of a conversation addressed by the ambiguous utterance. In other words, manipulating the QUD should lead to clear effects on utterance endorsement in a truth-value judgment task. So if we ask the question, did all of the horses jump over the fence? This every not sentence provides a full answer, that is, no, under either scope interpretation. And so participants should endorse it. With none, the every not utterance is a particularly ineffective means of conveying that it is not the case that none of the agents completed the action. So participants should be unlikely to endorse the utterance. With how many as a QUD, the every not utterance provides a full answer only under the surface interpretation. Therefore, endorsement rates should be somewhere in between all and none. Savinelli and colleagues use a rational speech act model to formalize the role of QUDs in utterance endorsement. The model predicted that people would be most likely to endorse the ambiguous utterance under QUD all and be least likely to accept it under QUD none. We decided to test whether these model predictions hold, testing the role of QUDs starting with English, but also other languages, looking at the status of ambiguity resolution and the role of QUDs beyond English. We focus on Spanish, a language that we expect to allow ambiguity similar to that in English. And we also tested Mandarin, a language reported not to have scope ambiguity in these sentences.
In our study, we run a choose value judgment task in English, Spanish, and Mandarin. In this task, people were asked to rate whether they think the every not sentence can describe the scenario. Our task is web-based, and here is the screenshot of our English task. People read the story and rate if the sentence can accurately describe the story. The bottom here is the choose value judgment task. People move the slider to decide whether they agree with what elephant says as a description of the story they've read. In this trial, participants see the all QD. Crucially, this is a between-subject single trial experiment, so participants were randomly assigned to one of the three QDs and completed only one trial. To increase the saliency of the QUD, we also provided explicit goal structure, which gave participants the possible answers to the QUD. Before presenting our experimental results, let's recall what Savinelli et al.'s model predictions look like. The model predicts the highest endorsement rate with the all QUD and the lowest endorsement rate with a non-QUD. Now, here are the experimental results for English, which confirm the model predictions. The predictions are partially confirmed in Spanish. Comparing Spanish results to English results, we found a similar QUD effect for the all QUD, which has the highest endorsement rate, but we didn't see the effect of non-QUD manipulation in Spanish. The Mandarin results show that Mandarin speakers always rated the sentence low, regardless of the QUDs. This result suggests that Mandarin does not allow ambiguity in the ever not sentence, as expected from reports in the literature. If you are interested in our study and want to learn more about how we adapted the Savinelli et al. Model to capture the Spanish and Mandarin results, please visit our poster session and ask us some questions, or you can access the PDF of the poster through the link. Thank you.